So, hi everybody and welcome back to C++ tutorial series for absolute beginners. This video 240, and in this video we continue with our exercise, and I was creating a sort and I stopped at step 4. We have discussed the step 4, which was just comparing two pointers. Let me show you the picture. That is this one. Here we have first one, the second one, and we have to compare this so that we can decide if we have to swap this, because we want the bigger numbers all time to the right side. After we compare them, then we go to the next pair and then we swap again the bigger number to the right side till we go to the end. All right, that was the step 4. That was just how we compare, but we have not filled out the body. So which means what happens after we compare? So what happens if this first number is bigger than this second number? So, and for this step I have here step 5. You can see it's here. Let's copy this one, let's paste this one here, and let's comment this fast out. Let's format this. Let's write step 5 because that was my step 5. But step 5, you already noticed probably here, step 5 is here commented out, which means that was not a good solution, or I have changed something, or it was wrong. We will see it in a moment why this is so, but let's see what I did. First of all, let's go here first to our picture, and now I'm right now here that I have compared this one, and I can see the state is bigger than this one, because when we see here the condition, this condition will only go into the first block if this is true. We learned this with if statements. And if it is only true in my case for this example, when the first number is bigger. So you can see the first number here is indeed bigger. So it will go in this condition. So we have make sure that it goes here. And let's see what I do here. So first of all, you can see I create a variable, and interesting is it is called temporal node for score data. Why is this so interesting? Because I am doing here just a swap. So these are just swap steps. Of course, I should comment this out, but let's I skip this commenting because it will take a little bit too much time. Let's write at least swap in. Swap. So I make here a swap. To make a swap, this is the whole swap procedure or steps, and I have to do something. First of all, you can see I created a variable which is a node. Interesting is it is not a pointer. Till now we worked more or less with pointers. You can see I created here a pointer, the head pointer, and these nodes here which was created, they are heap nodes. What I mean with heap nodes is, you probably know it, or you should know it. Heap nodes means this node here is created with this create node, and this create node is using the keyword new, and that's why I call them heap nodes, because they are created on the heap, and there are if you create something on the heap, you need an access point. In our case, it's this head. Okay, that's fine. And here you can see now in this case, in our step 5, here I create a normal node. Let's create here a normal node. So let's write it here. I create this normal node here, and you can see what you can see else. It's a temp called temp. Temp means all time it is temporarily for use case in most cases, which means you are creating this one, you are using it, and then it is destroyed. And it is here in the scope, which means it is created here. This temp node is used here in the scope, and after this end scope, this temp will be destroyed. So it has only a use case to do something. And in my case, what I want is I want swap here now this two numbers, because it is fulfilling this condition here. Yes, the right left side, this is this one, is indeed bigger than the right side. I want swap them. All right, let's go to the next step. I created here the temp here. Let's make a fast repetition of class why I can create this temp here like this. I mean this node here again. Think about it. We can hover my mouse over it. Let's press F12 so that we jump to the definition, and you can see we have here a constructor, a parameter with parameter, but here important, I have also give this parameter a default value, which means now I can call this node, when I create a variable with parameters, like so, so I give here any int number, or I can use no parameters, because then this default value will be automatically used here. That's the reason why I can create here this node. But now the next question, why I use this again, this temporal node, for what? For what I use this? And this temporary node here is used to save the value from one of this one here, and then I assign the value from here to here. Let me show this a little bit better. So first of all, this number here, I start here with this 63. I want that this 63 is here and 50 here, but I can't directly go there. That's why I save this 63 value first here. So go here in here, and then I say, okay, let's keep this one here, 33. I save this here, so the same value. And important is here I just create a copy. So this one stays still here, but I save this here as well. So I have it now in 2 places. And then what I do next step, after I saved it here, this value, I know I can replace now this 63. And how I replace it? Because I said, okay, I want this 50 here. So I just assign the 50 here, and when I assign to this node, this 50, this will be replaced. All right, but you can see I have saved this value here. After I assign this one here, I can assign the saved value now to this place here, which is replacing this value. And 50 is then here on first, and 63 is here. And that is exactly that what I do now here in the next steps. All right. This is so to understand a little bit. Let's see if this is how this looks like in code. And in code, you can see I created here the first. Let's see why it's complaining. Oh no, there is a complaint. Oh yes, now I can see. Score. Because I'm it here in space. All right, so we can see I created here this temporary data. That was this one. The next step is I want to save this value here, because this value will be replaced with 50. So what I do is here, this temporal node, save please the 63. So what I did is here, you can see, I take here the variable name. Important is because this one is a normal node class, not a pointer class. We are using what? We are using this dot. The normal access specifier, dot access specifier, and the node class has the score data. We know this, so let's go here fast in our node again, jump up, and we see we have here the score data. Here I can save this, and then I go back to this place. And then I said, okay, to the score data I assign it. And important, you can see again here, I use now the pointer, swap pointer first position. This is this one. This pointer is pointing to this node. I say to the pointer, okay, get me this value here. Here the pointer said, okay, I'm the pointer, and this is the pointer access specifier, and the pointer is accessing the score data, which is this 63. And you can see here there are 2 different ways how we can access, but important is you can access it this way and assign it to the other one. So that's why this assignment is working. The assignment, there is no problem, because in the end we have here just an int, right? I have here an int, and here I have also an int. That's very important. And I assigned this one just here. That was the first step what I showed you before. First we assign here this one in. Okay, the next step is after I have saved now the 63 in code, I want assign this 50 here and the 63 here. First I assign the 50 here. Why I have to assign 50 first here and not 63 here? The reason is I have saved 63 here. And I have not saved 50, which means I have to use 50 now first, or I have to create another temp node, but that would be additional work, so I skip this. Instead, I say, okay, I have not saved 50, but I can 50 assign directly, so I assign directly here. And then this one is replaced, and you can see 63 I can assign here and destroy then this or replace then 50. That's why you have to assign 50 first here, and then the 63 from here. All right, and the next step I do exactly the same thing. You can see here swap pointer first position. This is this one here. Now I accessing this place, the score data through the pointer. Here I accessing through the pointer to the score data, and I say, okay, assign to this place, please, the swap position second position score data, which means go to this pointer, go to score data, get this 50 and assign it here. Very easy, straightforward. And then after I finish this one is now 50, this place here, it is replaced, and now I want to replace this 50, but the good thing is this 63 here is replaced. So you have here not 63, but we have here 63, which is good. So we can now use this temporarily here to assign this one, and in the next step I do this one. Very nice. You can see again how I assign this. First of all, you can see I access this node here with the second pointer. In my case it is called swap pointer second position score data. All right, get and then assign again this pointer means assign the score data, which means from the class I want the score data, which is right now 50. At this point it is 50, but now I assign it a new value. The new value will be this value, and let's see what this new value is. You can see it is called the temporal node for second data, which is my temp here. This temp here, and get the score data and assign it here. And again, here again I use the normal node. That's why I have here a dot access specifier, and when I use a pointer I have all time the pointer access specifier. And that was already my swap in this case. And here you can see here was one more node. Important is that I use not here the new keyword, which is also nice. If you can avoid the keyword new, it's all time nice, and the reason for that is then you have not to manage memory allocation. So in my case I can avoid it because it's just a temporal node just for use case, so we don't need something on the heap here. All right, with that said, let's go to step 6 and see what we have to do next. And step 6 is where, let me search this with Control 6, and here is one of the 6, but not the one which I need. And this also not. Here it is. Here I have step 6. So the step 6 is this one here. You can see here are actually 2 steps, but we ignore this one. We are here. Step 6 means we need probably a while loop. Let's copy this one here. Let's copy the while loop. And right here, step 6. And let's see why I need a while loop. I mean, normally, I don't know if I need a while loop. This one comes later. Let me explain it here. So here, I finished now the step. I have changed this one, right? Let's make this faster. Copy of this one. Paste this, make here faster new. Let's do something like so. Let's get the new values here fast. Here was, that's not so important, the numbers here now. Make here this one, and right here 50. So this is that what we have, right? 50 and 63, or I should copy all normally, but whatever. So this step is finished, and what I want now is the pointers. You can see I finished here the swap, but the pointers here are at the same place. I want now, like in the Wikipedia animation, like bubble sort, that the pointer are moving one step to the side. So I want that the first here becomes here first. Let's make here past one more or 2 more. So, and you can see is this black here, is this one, okay, around this. So I want now that first goes to this place first, and the second should go here to this place. But how I make this? This is the question now, because I want my goal is to compare now these two pairs. You can see we are trying to do that what the Wikipedia animation is doing. We're going all time comparing and then moving one step here to this one. So you can see when I move from here, I just move one step here. And when I move from second, I move just one step here. So, and how we are doing this? Actually, it's very easy. First of all, I start not even with the while loop, I think. I think this while loop is not the step 6. Step 6 is more... step 6 is more that I move it. Okay. In my case, normally I would say how I move this, but important is here that I want come from this place to this place, and there are different ways. I used a while loop. You could use also another loop, a do while loop, a for loop, and on the Wikipedia page we saw they used a for loop, but they used also an array. Arrays are good for for loops, but we have here a linked list, so we have to be careful if we can use a for loop. Probably we can, but it's then a little bit you have to code more, because then you have to make here counters and so on. But I will choose a while loop. And a while loop, we learned, let's go here to the while loop. We learned we have here a condition, and let's create first of all the right while loop syntax. So this is the right while loop syntax, but we can see we have here a condition, and this condition we have to define. The while loop is only here that I move from here to here. And before I can define here the condition, I want to assign now this move here. How I can move this? Very easy actually, but I'm wondering where I put it in. 7, let's see if I have it on 8. Where I put it in. Here is it. So here is 5, 6, 7. Nah, not really. So the normal approach is what you do is you just get access to this first part and then get to the pointer and set just point to the next pointer. I'm just wondering where I made this. I made this here on step 12 anyhow. Don't know why. Perhaps I made here a little number mistake, but whatever. Let's keep here on the while loop. So my goal is that I move here to the right side. And when I move here to the right side, I have a problem, because we know when we use a while loop, in my case, I use a while loop, and I while loop need all time this condition. And the question is now, okay, I have here an array, a linked list. It is not an array, it is a linked list. Very important, because an array you can just count how many elements, and then you have a range, and then you can exactly try to figure out with the range. But here I have a linked list, and a linked list has just a head start point, and then I have to find a way to move here to the right side. Okay, and important is I have to find anyhow a end position, because the loop starts and this condition here will say, okay, when I should stop. So where is the part where I stop? In my case, I said, okay, I can try to figure out how long this array is. Then I can try to count all my steps. And there are different kind of solutions. You can see here are random solutions, good solution, bad solutions. I don't even know if my solution is good or bad, probably not, but nobody cares about this, because we are trying this for the first time. It's a prototype. Prototype means all time just do the first idea which you think is good, try it, and then research later after you finish this program if you find better solutions. In our case, we are in the state where we're just trying to finish this program, which means I say, okay, my first idea is we can count, but when I count, that could be a lot of work, perhaps. Then I had a second idea. I said, hey, why not create one more pointer? Oh my god, now we create one more pointer. And the pointer which I create is the while loop will all time loop through till it is here at this endpoint. So why not create here just a pointer which says I am the end, so a end pointer. And then all time when I loop here, then to see the pointer, end pointer here, I know this is the end pointer. And then I can start over again with the loop, because we saw in the Wikipedia animation that the bubble sort goes through till it till this big number is here, and then it starts again for the other iteration steps. All right, but I have now an endpoint, and what I have to do is later just switch this endpoint all time a little bit to this side. But first of all, let's define this endpoint. So you can see my while loop here is just to choose my strategy, how I want loop through this one. I choose this while loop. Let's go to the 7. 7 is, in my case, creating this pointer, right? And in my case, I created a just normal pointer. And let's see. List, yes, I try to pointer and position. Yeah, this is exactly what I explained here. So let's make here a 7. And important is here you can see when you create a pointer, which is the end position, I use this here in this condition later, because like I said, I want loop. The loop will go till this point and it will realize here is the end. All right, first of all, let's write here step 7. Step 7. And then I said, okay, we create this pointer. Let's create this pointer. And I called this loop end position pointer because here is my loop, because it is just used for the while loop, and here is the end position all time. It indicates the end position for the loop all time, so it can start over again or it can terminate, and we will see. All right, I have finished this one. Let's go to the next step. 7 finished, and I need step 8 here. Let me see, where is step 8? 8 is here, and here I make, all right, here it's a little bit double mubble. We skip this part 11 here. We make here a if, and I need just this if condition for this one here. And I will explain what I do here in a moment. Copy. Well, let's copy the whole thing. Let's copy the whole thing. And let's place this here in our, let's write here step 8. Let's place in. And now we will skip this one. I kick this out because this is step 8. Okay, and when I kick this out, you can see here also a strange style. And the reason why I have here a strange style is the if statement here. You can see I used here an if statement, a very strange style. And the reason for that was later this if here becomes very long. I compare here, or no, I make a logical or here with 2 long things. Instead of putting it all in one line, I just said, okay, that's too long. I want to make it readable, and I want not scroll all time in this position. So I just make it in 2 lines, and that's why this if looks a little bit strange. But careful, you have just to keep in mind how the syntax of a if works. It starts with a here round brackets, close brackets for the condition, and curly brackets for the body. So don't get irritated by the style, because style is sometimes different. So in our case, let's go back. My thing is, I have defined here this end position, and that is this end position for the loop. And here I need this end position for the loop before I go here. Also here at my condition setting, because I have to figure out anyhow how I can use this end position pointer now, so that this is stopping here. And I said, okay, the easiest way is I have here now a pointer who is indicating my end position. I have just to compare what, let me watch what I compared here. Not that I compare something else with different things. Where is it? So loop end position pointer is not equal. Yes, this is not equal head position pointer. This one is this one is actually not so obvious what I do here. I thought it's obvious. So let's see what this condition is. The loop and this loop end position pointer is clear. That is that one. That is our end position pointer. But I say this loop should stop when my loop comes here, and it sees this one here. It should stop and start over again. But when I watch this condition here a little bit more in detail, it says it will stop when it's not head of linked list param, which is actually the array input, which means it is our head. So my loop end position, let's make here an end as well so that I can show you here. This is my end pointer. In my case, I compare this end with this head, which means the head will stay all time here, but my loop will go here and it should stop here. So I have a problem. Why I compare this one here with this one here? The reason for that is this while loop, which I create here, is the while loop for the whole sort. So this will stop. This while loop will stop when this whole sort is finished, not an iteration, but we have here iterations. And I think this was not the easiest solution. I just come up with this one. So what I did next, let's see what I did next. So let's go into this. Before I explain this one here more in detail, let's finish the other steps, because this step is not really defined here at this point. This step indicates only this while loop will finish, like I said before, when the whole sort is finished. But we have to find this point, because like I said, I loop here this pair, then I go here, loop here, then go here, and at this point I want that the loop should stop and go back. So, and let's see what I did there. And this is in step 8. I made a condition. I said, okay, let's try to figure this out. How I find this. It's not easy. I thought a little bit, and then you can see what I did. I said, okay, the swap second position pointer. This is my second position pointer here. This one here. Let's make it here the color red. I used this one here, and I said get access to pointer to next node. The pointer to next node, we know. What is the pointer to next node? Pointer to next node is this one. So this pointer is pointing here and is accessing all time of this node's pointer. And this one is this one. All right, so this one is the first line. And then I said if this is equal to null ptr. And this one, this is again our equal sign null ptr. If this is equal to null ptr, I know something. So what I know, because I said, hey, the last node here, which is my last node, this last node has of course also a pointer. It has one. I have not showed it here, but this one has also a pointer. And this last node has all time, and that I know in a linked list, or at least in my setup, a null ptr. The last node is all time null ptr. So, because I know that the last node is a null ptr, I know how I can now use this one as a condition to do something. What I want to do is, hey, when I check this pointer here and it is not a null ptr, I know exactly that this one is not the last place. So here, for example, in this case here, I check here, I just check, is this here the null ptr and this red one here? No, it is not null ptr, it's pointing to another node. So I know at this moment, this one here is not the last place. So then later, because we know it's a while loop, the while loop will later go here and here anytime later. The second one will be here. I don't know when, but I know it's a loop and will come here. And when the second one comes here, and the second one is then pointing here and say checks again of this node, get me your pointer. Is your pointer to next a null pointer? Yes, then I know you are the last node, because null PTR is only defined one time. We define it only one time, and this is very important. This is only defined at the start. So I use this information. You say, okay, here I use this information as my condition. So the question is condition for what? And you can see I said here step 8, last node. We've tried to figure it out, the last node. That what I tried to explain it. Here with this null PTR, I know this is the last node in my linked list. And now I do what? And that's the step, let's see what I thought then. Step 9, loop end position pointer. That was the end loop here. We have created this before. You can see that was on step, but you can see we created it with a null PTR, which means we have not assigned it. It is just created. This pointer is not assigned. This looks already like assigned, but it was not assigned. So, and the assignment place is exactly here. Step 9. I say, okay, now I use this information when the while loop comes to this null PTR in the first iteration. I can set this end position pointer. Now I can assign it later. Or you could find also different ways. For example, you can, I don't know, another way to loop through, through loop and then assignment, but this would be additional work. I said I will loop here anyway and can wait till I found this null pointer and set, and after I find this null PTR, I assigned my loop and position pointer. So you can see here, step 7 was just, I said I need a pointer to the end position, but at this point when I create this pointer, that was this step here, I don't know where the end position is. And in step 8, I said, okay, the end position pointer I can figure out when I find the null PTR, because the null PTR from a node is only created on the last node. All other nodes here between, you can see this 30, 50, they have also pointers, but they are not null PTR. Only the last one has this one null PTR. And that's why I created this condition here and said, okay, now loop end position pointer, here this one, you can be assigned when this condition is true. So that was the condition. So the second one here is looping here to this point. And then it's asking for if this has a null PTR, yes. And then, yeah, you can assign me this one. And you can see what I did. I take the created loop end position pointer here. And I create important here. What I did here, you can see this is also important. That you use here the swap pointer second position and not here I do have to use the pointer. The second, like I said, is a pointer. But important is that you're not asking here for something like this one for the next node. This would be wrong. Here is our, where is the player to the next pointer to next node. This one you should not do here. The reason for this is the second one will be later here. It's pointing to this node. And you should not ask now when I point here to the next node. Because this end position pointer should just point to this node, not where this other pointer is. All right, this is very important here to note, so don't make this one. Position, I think that was this. So that was just to find, so you can see all did what I hear is just to find this end position without looping before, just because I know it will loop here anyway. All right, let's go here to the step 10. And now that was the step which I wanted to show you before. I don't know why I made this on 10. Because the step 10 is I said, hey, when I loop here, because here, when I start to loop, right? Or let's see, this is not this thing. Is this that? So we have here stop first position, head of linked list param. And then this is very strange. This is not the thing I for pointer second. Oh, that's a little bit strange because this one is here. Ah, yes, now I see. Okay. Okay, the first strange point is because this should not work because this is in a if condition. I don't know how it works right now. All right, now I get it. Sorry. This is something other thing. Sorry, I was confused a little bit with this one. So my confusion was I wanted to show you that how this while loop, these two pointers are moving to this one, but actually these two things, what I did here in step 10 is something other. So let's see what I did here. Here I realized, okay, this one here, again, we go back to the condition. The condition says, hey, you are at the end of this linked list. At the end of this linked list means anyhow these two pointers walked till to this place here, to the end. So with other words, now my first is pointing here and my second is pointing here. And here one more note, it is important that you use the second pointer here, not the first, because if you would use here the first as the end pointer, then you would create here a problem when you are going all time one step to the right side, because here this one would try to use the null pointer to go to the one side. That's why I have to use the second one, the second pointer here. That's also a note, but let's go here to this step and see what I did here. Here I said, okay, now I realized I'm here at the end of this array. Now all I did here, you can see, is this thing. I set then the loop end position pointer. Yes, now I have defined my end, because first I have created it here on top. I defined end, but at this point, this first and second is not at this point. They are here at the end. The second is on the end. The first is one before. So, but here the loop should start over again, right? That's why I have to reassign these two pointers back to the start, because here is the end. The end means, okay, you have reached now the end. You should, these two other pointers should go and start over again and do and try to check the next value. For example, here we have found here 63 would be later here. 50, they would start now to compare 50 with this one, which was here changed, and then try to get again here to the next step. All right, and this one is just, and this one is very easy, because if these two pointers are here, I just say, okay, go to the start the first one I say, which was, let's say, the first one would be, let me show you this better. The first one would be here, normal, before I first. And the second one would be here, second. And my condition is, when the second one reaches here the end position, I want go that this both should go to the start, which means I just say, I just assign first to the head again, because I know this head pointer here is all time the same, because this head pointer we already discussed in our linked list is our access point for our linked list. This is very important. This is all time the same, must stay all time the same. All right, then I can say, okay, assign it back to the head, which means it will go here back to this place. And the second, I say, okay, the second is just use the head again, but this time go ahead and ask for the node in this pointer, which means ask for this one. All right, so, and this was very strange to explain probably here, but in code it's very simple. In code you are just get the swap first position pointer that was here and go back to head, and you can see head of linked list param, which is here my head here. Just go from here back to this position. So it's again here after I finished. And the second thing you can see, I do the same. Very important, like I said, the second you can see we start again by head, but we have no here direct pointer. The node here is only connected with this one. That's why I have to ask head again for this node next to array, next to a pointer to next, which is this one here. So this was step 10. We have not figured out how we change here the pointers to the next step. Probably I made this in the next steps anyhow. Anyway, I hope you understand it so far. I won't stop this video here again, so it's not too long. And you can see there are, yes, I think anyhow it is not good, and I try it, and if it's not working, I try something else. So you can see this is just a random solutions. I have here different kind of random solutions while I try this. So the end solution here is random, how I set the pointers back perhaps, or I count. So you can see there are different kind of solutions, and I don't know if the solution right now which I try to do is good, but like I all time say, that's not very important. We are making a prototype, we are developing our code. We at the first time you just try to find a solution. Later, like I said, when you are finished with the sort, then you can rethink perhaps a little bit more solutions or try to optimize it and so on. So with that said, I stop here the video, and like all time, if you have any questions or any comments, write it in the comment section below. See you in the next video. Bye, good luck, and like all time, never give up and have fun.